Hi, in this video, I will be showing you problem number 37 of chapter 7 section 2. This is also a problem in the homework. Evaluate the integral pi by 4 to pi by 2, cotangent to the power 5 phi, cosecant cube phi d phi. So look at the formula here. Derivative of cotangent 5 is negative cosecant square 5. Derivative of cosecant 5 is negative cosecant 5 cotangent 5. So here, in this problem, the question is, what is the exponent of cosecant? What is the exponent of cotangent? And also we have to figure out which is the best choice to substitute, whether it is cotangent 5 or cosecant 5. So here we notice if cosecant exponent was even, if you look at this one, then we could have considered cotangent 5 as our u substitution. But being cosecant exponent being odd, we want to look at this one. Cosecant 5 cotangent 5 is derivative of cosecant 5. So our choice of u should only be cosecant 5. Okay, so we are going to write the given integral as I equal to integral pi by 4 through pi by 2 cotangent to the power 4 phi cotangent 5 to make it up to make up to 5, then cosecant square 5 times cosecant phi d phi. So we are going to write 3, exponent 3 as, we are going to split that as 2 and 1, exponent 5 as 4 and 1. So it is integral pi by 4 through pi by 2, cotangent to the power of 4 phi, and then cosecant square phi. Then you group the cosecant phi cotangent phi d phi to make it look like this, cosecant phi cotangent phi. Now we are going to substitute u equal to cosecant phi. So du would be negative cosecant phi cotangent phi d phi. Also, by changing the limits, whenever you make a substitution and if it's a definite limit, the given limits are for 5, you're going to change the limits to u. So the old limits and the new limits for u is cosecant phi. The lower limit initially is pi by 4. So the new limit is cosecant pi by 4, which is going to be root 2. The old limit, which is pi by 2, which is the limit for phi, upper limit for phi. The upper limit for u now is cosecant pi by 2, which is 1. So that the new limits are 2, 2 and 1. So we can write I as integral square root of 2 to 1. Then we are substituting u equal to cosecant phi. So we are going to write cotangent square as cosecant square minus 1. That is cotangent square, but that has been raised to square, so that will become cotangent to the power 4. Cosecant square phi times cosecant phi cotangent phi d phi. That is integral root 2 through 1. This is u square minus 1, the whole square, times u square. This whole thing becomes negative du. So when you are writing in terms of phi, you want to write the limits for phi when you are changing to the variable u, you want to change the limits also to represent the limits of u. So it is integral square root of 2 through 1. Expand this, which is u to the power 4 minus 2u square plus 1 times u square, and then you have a minus du. So because I have a minus, I can bring the minus sign out, or I can change the limits to 1 through square root of 2. Now you distribute the u square, so it is u to the power 6, 2u to u to the power 4 plus u square du, which will be u to the power 7 over 7 minus 2u to the power 5 over 5 plus u cube over 3 between the limits 1 and square root of 2. If you simplify, it's going to give us 22 over 105 square root of 2 minus 8 over 105. So at this point, you're going to use fundamental theorem of calculus part 2. So evaluate this expression at the upper limit, which is root 2, minus evaluate this expression at the lower limit at 1. If you simplify that computational part, it gives you this answer. Hope this video helps.